In 2.4 and 5, we're going to be solving quadratic equations, x squared, or equations that can be rewritten in terms of like an x squared. And the first thing I'm always going to tell you is try factoring. Factoring is the quickest, nicest, easiest way to solve a quadratic equation if it factors. If it doesn't factor, we have a couple of other methods you can revert to. But if it factors, you can be done within a minute versus having to resort to completing the square of the quadratic formula. So if your factoring skills are good, it's not going to be that bad. On this test, there's multiple problems. I believe there's only 14, but I set the conditions. I tell you, solve this problem using factoring. If you don't use factoring, I don't care if you get the right answer. If I don't see the work for factoring, 0 points. And then another problem where I say you have to do the problem using the complete the square method. So if you use something else and I don't see the work for completing the square, 0 points. Then another problem where you have to use the quadratic formula. So you have to know all the methods. And then the rest of the problems, it says solve it any way you want, as long as you show the algebraic method. So if you want to do completing the square on the rest of them, that's up to you. If you want to use the quadratic formula on the rest of them, that's up to you. But I'm going to keep telling you over and over again, try factor. Which means I'm going to try to set you up with something nice that factors. I wonder if I'll give you a review sheet. How it looks just. No. Maybe. But you practice. Yes, questions. Office hours, 2 study groups. It ain't going away. The test you just got back ain't going away. Final replaces your lowest test score. Today, office hour at noon. Last chance to do the bonus questions. No, you can't start at 11:50. You start at noon. Okay. So here we go. Factoring is just reversing multiplication. All of these are multiplication problems. So once we learn how to make sure we can multiply, then we undo it with factoring. Multiplication means we're going to distribute. Factoring means when you factor it out, you're going to divide it apart. You undo what's being done. So what we want to do is we want to see what's happening. I want to make sure we can do the multiplication first. Because when we did this on the chapter 1 test, f times g of x, we had trouble. On the test, first of all, I kept telling him you need to show the rewrite this. This is f of x times g of x. Rewrite it and then we substitute and pull up just a simple function. You can see what I'm talking about. I'll pull up the functions for Monday, Wednesday class. Way too long. So number 12 on the test, f of x was given as 8 minus x, or 6, no, sorry, g times h. On this version, it was g times h, so g of x times h of x. On this version, g of x was given as x squared minus 4x, and then h of x was given as 5x plus 4. And all of the examples that we did, you had to rewrite it. So g times h of x is g of x times h of x. Rewrite it, and even put this on the board during the test, beginning of the test, make sure you do that. Then you substitute g of x, x squared minus 4x. And you're going to multiply this times h of x, so you have to put it in parentheses. Times h of x, so times 5x plus 4. And if you don't put it in parentheses, you're not multiplying all of this times all of that. And then when you multiply, you're doing distribution. This first term multiplies by each one. The second term multiplies by each one. Now, I notice on some tests, you actually write that out. You go x squared times the 5x plus 4. And then you do the negative 4x and you write it out 5x plus 4. And that's fine. And then you do each individual distribution. It's going to get ugly. It's going to get uglier than what we have. So I don't know if you want to keep that method. That's up to you. Eventually, you need to evolve and do the rainbow, like Skittles. If you have to, it's x squared times that 5x and write it out. But what you need to be able to do is see that this x squared times 5x is the first, x squared times x is x to the third. So we have a 5x to the third. If you need to see this, then you do this. But you should be at this part. X squared times 5x is 5x to the third. And then you got to get your signs right. The next one, when you distribute this first term times the last term, it's a positive times a positive, so you need a plus. This x squared times that 4 is just plus 4x squared. It's just distribution. We distribute the first term to both of those. So the first term is done. Now we distribute the second term. And when we do that, you got to pay attention to the sign. So when you distribute, it's a negative 4x times a positive 5x. Focus on it's a negative times a positive, so that's going to be a negative. And you're going to have a 4x times a 5x. And where I see mistakes happening is, all I saw was a 20x. You didn't multiply the x's and get an x squared. X times x is x squared. So you're losing out on two light terms right here. Details. And then last times last, negative times a positive is going to be a negative. You have a 4x. And then times a 4. I'm not bringing negative 4 times that positive 4. I'm doing negative times a positive is a negative. That's how I'm getting the sign. I'm not thinking negative 4x. I'm thinking it's a negative times a positive. So my sign's going to be a negative. Then I do 4x times 4. So I take care of the sign, then I do the multiplication. But the mistake that I kept seeing was they basically ignoring the x and thinking just 4 times 4. But there's an x here. So if you need to write it out, you write it out. But you should be able to go, all right, 4x times 4, 4 times 4 is 16, and there's an x. So minus 16x. Missing this, if this is x to the third, these two are x squared, and that's an x to the first. So your two like terms you can combine together are those two. So you have 5x to the third. Positive 4x squared, take away 20x squared is negative 16x squared, and a minus 16x. Multiply. We can't divide unless we know how to multiply. We can't factor unless we know how to multiply. When we multiply them together, the next thing is we take them apart. What does this look like before it was multiplied? So we got to pull it apart. We got to undo the multiplication. What times what equals 5x to the third minus 16x squared minus 16x. Okay. So we're going to go through the multiplication. I'm going to give you answers, and then I'm going to let you basically ask which one you want to see. We have 3x plus 12. This is 10x squared minus 15x. This is 12x to the fourth minus 32x to the third plus 28x to the second. This is negative 12x to the fifth, y to the fifth, plus 27x to the fourth, y to the seventh. Number 4. So there's a lot going on. A whole lot. So maybe we need to see it one thing at a time. So we distribute a negative times a positive. Just care about signs. Negative times a positive will be a negative. And then I have this 3x to the second, y to the third, times that 4x to the third, y to the second. And then we distribute a negative times a negative is going to be a positive. And we have 3x squared, y to the third, times that 9, x squared, y to the fourth. Rules of exponents. When you multiply, you add the exponents. So negative. And here's what's really going on. I'm actually going to rewrite this as a negative, and you have 3 times x squared times y to the third times 4 times x to the third times y squared. Okay? The commutative property of multiplication. The commutative property says if you have a times b, that's the same thing as b times a. You can rearrange it and you still get the same answer. 2 times 3, 3 times 2, same answer. So what I can do, so you can see why this works, is I can rearrange terms. I can switch the 4 and the y. So then I can switch, if 4 is here now, I can switch the 4 with the x squared. So negative 3 times the 4. The 4 can end up over here. The x squared is here. I can switch the x squared with the y. So I'll end up with this x squared times that x to the third times y to the third times that y squared. You don't have to do this, but the reason why we'll just bypass it is because of the commutative property. I can rearrange it so The constants, the coefficients are next to each other and just multiply. The x's are right next to each other, so I'm just going to multiply. And the y's are right next to each other, so I can just multiply. There's a reason in math that says, before you just assume you can do it, that you actually can do this. So you don't have to do this, but this is what I do. Negative 3 times 4, so 3 times 4, that's a negative 12. X squared times x to the third. You add the exponent. 2 plus 3, that's x to the fifth. Y to the third times y squared. 3 plus 2, that's y to the fifth. Okay? Yeah.
Where I messed up was I was trying to multiply everything by 1 side of the third instead of the whole thing. So if it, and hypothetically, if you get rid of the negative 3x, it was just 1 y to the third, that wouldn't multiply in. And you'd have to lump the whole thing and start with the negative.
So if it was just this.
Yeah, that's where I messed up. Is I was trying to multiply the whole thing by y third and ignore the negative 3x squared. So if you can multiply everything by the entire. I didn't realize you can multiply everything by the entire.
Well, this is all one thing.
Oh, okay.
So the whole thing has to distribute. The whole thing is one. It's like distributing a 3. That whole 3 distributes. The whole 5x distributes. The whole 4x squared is distributed. Because it's one term. Because it's all held together with multiplication.
Okay.
Okay, there's one thing on the outside, negative 3x squared y to the third. So this one thing, one term, is distributed to the 2 terms on the inside.
If there were like pluses or negatives between them, would that separate?
Now you're doing, yes. Now you have to distribute. So if there was like 3x squared plus a y to the third, there would be another parenthesis like that. If there was a plus to y to the third, then you'd have parentheses, and then you would have to distribute the first one to both, and then distribute the y to the third one.
Okay, that's my last question. So like hypothetically, like if it was 3x squared, 2y third, would that still be an entire little?
Well, I would simplify the outside first. So 3x squared times 2y to the third. So I multiply 3 times 2, I get a 6. So again, we would try to simplify what we can do before we actually go multiplying in. So if this was 3x squared and this was a 2y to the third, I would multiply the 3 times 2 and distribute negative 6 x squared y to the third.
Oh, okay.
Because I don't want to, I mean, if I can simplify something, do it.
Okay, cool. Thank you.
Yeah. All right. So now this is a positive. Okay. And I'm not gonna do this part. 3 times 9 is 27. X squared times x squared, so 2 plus 2, that's x to the 4. Y to the third times y to the fourth, 3 plus 4, that's y to the 7th. So plus 27 x to the 4th, y to the 7th. And you can't go any further because they are not like terms. You cannot combine them together. Think about it. If you think you can combine the negative 12 x to the 5th y to the 5th plus 27 x to the 4th y to the 7th, what do you have? Do you have x to the 5th y to the 5th? Or do you have x to the 4th y to the 7th? What do you end up with? Because that negative 12 and 27, that's going to be a 15. Do you end up with 15 x to the 5th y to the 5th? Or do you end up with 15 x to the 4th y to the 7th? They're not the same thing. You can't combine them. That's as far as it goes. Like terms, the variable parts have to be exactly the same thing. The same variables, the same letters, and the same powers on them. So they would have to either both be x to the 5th y to the 5th. So now I have negative 12 of these x to the 5th y to the 5th, positive 27 of these x to the 5th y to the 5th. So now I have positive 15 of these X to the fifth, Y to the fifth, because they're the same kind of thing. But they're not. Any others on this? What to do? Number 3. So it's one term multiply into 3 terms. First thing you do is make sure you take care of your sign. So this is a positive times a positive. It's going to be 4x squared times that 3x squared. But I'm hoping that you start seeing you're going to get a 4 times 3, so you get 12. X squared times x squared is x to the 4th power. Then you have a positive times a negative, so that's going to be a negative. And you have 4x squared times an 8x. So 4 times 8 is 32. X squared times x is x to the 3rd power. And then you have a positive times a positive. So that's going to be plus. You have a 4x squared times that 7. So 4x squared times 7, 4 times 7 is 28 with an x squared. Yeah, you don't have to show that middle step. When you do it, you might want to say this, mumble this to yourself out loud or have that voice in your head. 4x squared times 3x squared, 4 times 3 is 12, x squared times x squared, x 4. Positive times negative, 4 times 8 for x squared times. So you hear it as you're doing it, as you see it. It makes a difference. It does make a difference. But if you're bugging the person next to you, then mumble lower. Okay. And I honestly believe that those little rainbows help organize what you're doing. Okay, we have done questions like 5 and 6 so many times. This is going to be x squared plus 4x plus 4. This one is 16x squared minus 40x plus 25. This has to be your best friend coming up. This is going to be 49x squared minus 64y squared. This is just a variation of number 5. This is going to be 9x to the 4th plus 48 x squared y to the 3rd plus 64y to the 6th. And then panic sets in because it's a fraction, but this is going to equal 9 over 25 x squared, and it's going to be minus 3/5 x, and it's going to be plus 1/4. So out of that list, what do you want to see? Which one?
9.
Number 9. Again, you have to, whenever you ask number 9, you got to say it number 9, number 9, or you say, tell me on Deadman, tell me on Deadman, tell me on Deadman. Because when you say number 9 backwards, it's tell me on Deadman. Beatles, Wyoming, 1970. If you use the shortcut, you use the special product. This is a minus b squared, which is a squared minus 2 times ab. plus b squared. So if you're going to apply the special product to this, you square the first term. So we're going to square 3/5 x. 3/5x is going to get squared. Minus 2 times a, which is 3/5x, times b, which is 1/2, plus b squared, so plus 1/2 squared. So if you choose to use the special product, that's how it would apply to something that looks like 3/5 x minus 1/2. A squared minus 2ab plus b squared. No matter what you do, when you have two terms, subtraction, and you have it squared. So when I do a squared, everything in the parentheses is going to get squared. When you have this one squared, a fraction, that's the rule of exponent. When you have a fraction a over b to a power, the numerator and denominator both get raised to that power. So the numerator to the second is 9, 3 squared. The denominator, 5 to the second, that's a 25. And then you have x to the second, x squared. So that's where my 9/5 squared, 3/5 squared becomes 9/25 x squared. And then minus 2 times a times b. You multiply these together, and then you double. So if I multiply 3/5 times 1/2, so that's 3 times 1 over 5 times 2 is 10, but then I'm going to double that. 2 goes into 10 5 times. I'm left with minus 3/5. And then there's that x. Now, I didn't actually do that in my head. I knew I'm going to go minus 2 times AB, and I have 2 times, over here I have a half. So that 2 is going to go into that half and reduce it. I just have 3/5 left over. Not because I'm smart, but because I've done a whole bunch of these. It's called practicing. Okay. And then 1/2 squared. So you square the 1 and you square the 2, and that's how I get the 1/4. If you don't want to get special product, it's 3/5 x minus 1/2 times 3/5x minus 1/2. Now, I apologize for my handwriting. It's my both shoulders are like shot. And for some reason, this one is messed up more this week than it's next. I'm not going to try to do the fractions as I just did. I'm just going to write it. So this 3/5x times the other 3/5x. And then a positive times a negative. Going to be a negative, and I have 3/5x times that. And then I have a negative times a positive. So that's going to be a negative. And I have 1/2 times this 3/5x. And then I have a negative times a negative, so that's going to be a positive. And I have 1/2 times 1/2. So when you multiply fractions, it's numerator times numerator over denominator times denominator, straight up. 3 times 3 is 9. 5 times 5 is 25. X times x gives you the x squared. Same thing here. This is minus 3 times 1 is 3. 5 times 2 is 10, so it's 3/10 x. That's going to be the same answer, negative 1 times 3, 2 times 5, 10. So 3/10 x.
And then 1/2 times 1/2, 1 times 1 is 1, 2 times 2 is 4. So we have two like terms. We have this 9/25 x squared, not a like term with anything. But this is -3/10 x to the first, -3/10 x to the first. So -3/10, another -3/10 is -6/10 x to the first, and a plus 1/4.
Every single test quiz you're ever going to take, the directions say simplify, reduce to lowest terms.
Common factor for 6 and 10 is a 2. 2 times 3, 2 times 5, the 2's reduce. 9/25 x squared minus 3/5 is what you have left over, 3/5x, and plus 1/4.
Wow, I can't get this problem wrong. Tried all a bunch of ways, I can't get it wrong. Because if you just follow the rules, you won't get it wrong. Take your time. Take your time and know that you have to distribute. Any others here on 5 through 9, we'll do those next Tuesday, but right now on 5 through 9, I'm going to give you the answers.
7,
Number 7.
48x squared and y to the third. Is it not 48x to the fourth and y to the fifth?
Oh, so you remember 8.
Yeah, number 8. Sorry.
So we square this, 9x to the fourth, and then 2ab. So 3 times 8 is 24. X squared, y to the third. So we have 2 times 3x squared times 8y to the third. So 3 times 8 is 24, and we double 24. 2 times 24, that's the 48. And then it's just x squared, y to the third.
Don't get double.
Well, doubling means multiply by 2.
So if I go left to right, this is 2 times 3x squared times 8y to the third. So if I rearrange it, it's 2 times 3 times 8 times x squared times y to the third. So this is what's getting doubled. So let's put it this way. If I multiply those two together, that's 24 x squared y to the third. I have 24 of those. I double this. So now I have 48 of them.
I don't change the exponents, because to change the exponents, I have to raise it to a power. I'm multiplying by 2. I'm not raising it to a power. Okay. And then here, this is 8y to the third. And then we're squaring it. So the 8 gets squared, and y to the third is going to get squared, 64. Power to a power you multiply. So 3 times 2 is how we get y to the 6. I think I really emphasized how important the rules of exponents were. They're really important. Can't make it up. So if you still have your rules of exponents, if you don't, go into the announcements. They're there, beginning of the semester. Have it out as you do these things so you are doing it correctly and you're not trying to make it up as you go along. You got to know the rule. So I'm going to give you these answers.
So this is going to be 48 x squared, and we're going to get negative 64x minus 35. And this is going to be 5 plus 2 square root 6. And this is going to be 2 minus 2 square root 15. This is going to be 1.
The last three questions with the square roots, that's 2.3. Going back to 10. If you were late, make sure you see me.